So now let us introduce the ratio test for series. So the ratio test actually is very powerful. And it says like this. So given series AN, this series can be any series, okay? Does not have any restrictions, about whether the term is positive, negative, or increasing, decreasing. There is no, not too much conditions, any series. And suppose limit as n goes to infinity, ratio, absolute value of an plus 1 over an equals, let's say, capital L. Okay. And then the ratio test says like this. Now, if this capital L is less than 1, and for sure, for here, this capital L can be greater or equal than 0, if it exists, then my series is absolutely convergent. Okay, it's a very powerful statement. 2. If this capital L is greater than 1, then my series diverges. Okay. Part 3, as you expect, if capital L happen to be 1 exactly, actually, there is no conclusion we can get. In other words, when capital L equals 1, the ratio test, you can think about it, it fails. Okay, we cannot tell whether this is convergent, divergent. Nothing what we can tell. We're going to need to change it to another test to give it a try. Okay, so that's about a ratio test. So now, maybe we work on one example here. So let's see, for example 1, if we have a series, let's say 2 to the power n plus 5 over 3 to the power n, okay, 3 to the power n. And an, it's 2n plus 5 over 3n. So in the an plus 1, which is 2 to the power n plus 1 plus 5 over 3 to the power n plus 1, okay. And then next is, we want to figure out, okay, absolute value of this, and then take the limit as n goes to infinity. But it turns out that this an plus 1 and an, in our problem, these are both positive. So what I can do here is 2n plus 1 plus 5 over 3 to the power n plus 1 over an equivalent to multiply the reciprocal of it, which is 3n over 2n plus 5. Okay. So as you can see that, we can simplify this into this way. So I can actually factor this 1 over 3 out times 2 to the power n plus 1 plus 5 over 2 to the power n plus 5. Okay. So that's what we get. And turns out, as n, let's say, goes to infinity, positive infinity, as you can see that this going to becomes into 1 over 3 times 2 to the power n plus 1 over 2 to the power n, which is 2, right? As n goes to infinity. So it turns out we have 3 over 2. Well, since 3 over 2 is a number, is less than 1. So based on the first conclusion, we know that our series, we can get that a series not only converges, actually is absolutely convergent. Okay, series is absolutely convergent. So that's a very straightforward example about the ratio test. Well, now let's look at another example here. It's like this. So let's see, example 2. So I have let's say 2n factorial over n factorial over n factorial. Okay, so this is a series. And our an, let's just copy and paste. Right? And our an plus 1 going to be, to be very careful, we're going to replace n with n plus 1, but I have a 2 in front, so it's going to be 2 times n plus 1 parentheses, then factorial over n plus 1 factorial times n plus 1 factorial, okay? And the absolute value of an plus 1 over an, again, those are all positive, so I write as 2n plus 2 factorial over n plus 1 factorial, n plus 1 factorial, oops. And the over an equals, is equivalent to multiply the reciprocal, so it's n factorial over 2n factorial, okay. So as we know that the n factorial is 1 times 2 times 3 up to n. So the n plus 1 factorial is going to be 1 times 2 times 3 up to n and then n plus 1, right? So in other words, n plus 1 factorial equals n factorial times n plus 1. Okay. And similarly, 2n plus 2 factorial, you can see that equals 2n factorial times 2n plus 1, and then times 2n plus 2. Okay. So with this in mind, we actually can simplify this ratio into this. So we're going to have it's 2n plus 1 times 2n plus 2. That's a simplification between this and this part. And over n plus 1 over n plus 1, okay? Because based on this inequality. And it turns out that, guys, you can see that you're going to have 4n squared plus, let's see, plus 6n, right? And then plus 2 over n squared plus 2n plus 1. Okay. So it turns out that as n goes to infinity, this limit going to equals 4. And we know that 4 is a number is greater than 1. So based on the ratio test, if the limit is greater than 1, then the series diverges. So we can get the conclusion that my series diverges. Okay? So hope this 2 example can help you to understand better about what the ratio test is. And as you can see that if a series involved with factorial or exponential, it's always a good start to use the ratio test. Okay, so thank you for watching and have a nice day.